Hi everyone, welcome to this channel, the Merchant Construct-preneurs and Tutors. Today we'll be looking at how to calculate earthworks required for cut and fill on site. Just as you can see from the image here, you can see that the site is not leveled, so there's an excavator here trying to cut and then fill other areas. So we are going to look at how to calculate this. Just a very simple and the simplest method of calculating the volume of earthworks that we require. So before we start, let us understand what earthworks really is or what earthworks are. Now, earthwork is foundational for construction as it prepares the ground for various structures, right? Like I said, earthwork is just like sand, your soil. So you need to make sure that your earthwork is perfect for whatever structure you want to put it, whether infrastructure, whether building projects, whatever thing you want to do on the soil. You make sure that it is strong enough. So now the earthwork, it involves techniques such as cutting, filling, trenching, and grading to prepare foundations, roads, tunnels, or drainage systems. So like I said, whether it is road you want to build, whether it's tunnel you want to do, whether it is drainage you want to do, you need to prepare your earthworks and make sure that you cut, you fill, you trim, you grade, just to make sure that you prepare it for various structures, right? Now, excavation is crucial in civil engineering and is performed using heavy equipment. Like you can see from this image here, you can see the excavator here. Behind, you also see like a backhoe there. Here you see your dump truck, or what we normally call tipper. So it carries the sand or the earth that has been either the one that you are borrowing. Okay, like in this image now, it is showing that we are actually dumping. It has been the soil has been borrowed and then it is dumping it on the site where it is needed, right? Okay, so this one, the excavator is excavating the soil. As you can see, the heap of soil behind and by the side there, it is excavating it. So proper leveling ensures stability and prevents structural failures, right? Accurate calculations also help in budgeting by providing realistic estimates for labor, materials, and equipment. So whatever we are doing, you don't just see a grader just grading the road, or you just see an excavator just excavating. Now this thing has been done. They are what we call, you take your levels and then you trim, you cut, or you fill to the required level, and then you make sure that it is very stable to prevent structural failures. So move on to the next slide. So the key points about this is earthwork is the process of moving soil or rock to prepare a construction site. Like from the image here, look at the two images side by side. Now this first side, soil is being prepared for the works. As you can see on the second side, you can see the work going on there. So earthwork is just the process of moving soil or rocks to prepare a construction site. Also, it involves two primary activities: cutting, that's removing excess soil, and filling, that's adding soil to low areas. So like we said, accurate earthwork calculation are necessary for estimating cost, optimizing resource use, and avoiding over excavation or underfilling. So these things are carefully done. That is the reason why we need to calculate the area or the volume of earth to be cut or to be filled or to be trimmed or to be graded. We just need to know how to do this thing and do it accurately, right? So moving on to the next one. So why adjust soil properties? Excavated soil become loose and takes up more space during transport. That is the swell. While compacted soil occupies less space when used for filling, shrinkage. Now, so when you ignore these factors, they can result to material shortages or excesses, right? When um you do not consider, like when you excavate the soil, when you dig, let me use the word dig so you understand. When you dig a soil, it swells. That is not the actual compact volume. When it's compacted, you see that it takes less shape. So we need to make sure that we consider these factors and then we will know the cost, and then make sure that we adjust these factors so that we have efficient material management. So why accurate calculation matters? Yeah, we have said it before. Ensure sufficient resources are allocated for excavation and filling. Minimizes waste and reduces cost. Prevent project delays caused by material shortages. Provides accurate estimates for budgeting and planning. So all these things we need to make sure that they have been put in place so that to avoid wasting of resources. Okay, so let's move on to the next slide. So we are going straight into steps to calculate the earthwork volume. Now, so there are different steps to do this. Now, the first thing is to obtain the topographical data. That what this simply means is the way the site is, just like from the image from the beginning or from the first page. Let's look at how the site is. So we need to get the details of various points, the low points, the high points, the mid points. So we need to know, okay, what do we want to do? Are we filling to the same level to the highest point, or we are filling following the shape of the gradient of the road, or what are we filling for? Are we cutting? You get, so all these things are considerations that will be taken into detail so that we'll be able to know what we are doing. Now, so the tools we use total station, we use the GPS, use the CAD software, you even use leveling instrument. That's like one of the um cheapest way of getting this. Use leveling instrument so to get the existing ground level, and then if you are cutting to a new level, use that to determine. You get, so there are different instruments you can use to obtain the topographical data. Now you divide the site into grids. You divide the site into grids, and grids. What we understand by grids, we divide it into equal shapes, like break the site into smaller sections for easy calculations. Now the third step is to calculate the depth. Calculate the depth at each grid point. Just as you have this, let me still refer to this image here. Let's say this portion here is one grid, where this excavator is another grid, another grid. So you just make sure that you do it step by step so that you're not going to get overwhelmed with the whole site. So determine the difference between the proposed finished level and the existing ground level. So we need to know whether we are cutting or we are filling. That is what this depth actually do for us, or what we aim to achieve. Now the next one is the volume calculation. Now there are different methods. So either you use the average end area method or trapezoidal rule to compute the volume. So here we are using the average end area method, and it's just the formula, volume area times depth, or length times breadth times depth. So depth times the grid area. So next step is to adjust the volumes. Now we said initially that loose sand, just as on this truck image here, loose sand has swollen. That is not the true volume until when it is dumped and then compacted. Then the compacted ones, we need to take care of that one too, to be sure that it is well compacted and we get the actual volume we are filling to. So we have different factors. So for the swell factor, it is between 20% to 30%, while compacted between, that's the shrinkage factor, between 5 to 10%. So these are the formulas for the adjusted volume. Adjusted volume for swelling, you have it as the calculated volume multiplied by 1 plus swell factor. For the shrinkage factor, the same thing. And then now you summarize the total volume, add all the grid volumes to determine the total excavation of field. When we go into the calculation, we understand this better, right? Okay, so let's move to the next. Okay, now so practical example. Now the area of site is 20 meters by 20 meters given. So the area 20 times 20 is 400 square meters, right? Now we are dividing the site into grid side, like into square, different square, 5 meter by 5 meters, 5 meter by 5 meters. So to every 25 square meter, we are dividing the site into it, so that it will be easier for us to calculate the volume and also adjust accordingly. Now, the next step, according to our step, is to calculate the depth at each grid point. Proposed finish level minus existing finish level. So let me go to the table so that we understand this thing here. So this is what we have here. The area of the site. Now we are divided into four grids. Grid A, B, C, and D. A1, A2, A3, and A4. Okay. So EGL means existing ground level. And the existing ground level for grid A is 1.5. Existing ground level for grid B is 1.4. For grid C, for grid A3 is 0.6. For the last grid is 1.2. Just imagine this image here, so you understand, or you appreciate what we are talking about. Or let me just copy this image to this last point so that we'll be able to get this get this okay. Okay, so let me just enlarge this so that um we'll be able to see and have a true image of what we are talking about here. Okay, so this is it here. Now the existing ground level, as we said, look at how the images, look at the existing level here. So from this image, at this end here, we have, this is the existing ground level. Look at the different levels. So you understand when some points are 0.6, some points are 1.3, 1.5, and the rest. So I'm using this image as an illustration. So now the proposed finish level, we are taking a uniform level, like we are taking a uniform level where it's 1 meter, 1.0, that is 1 meter. So the depth will now be the proposed minus the existing, right? So 1.0 minus 1.5 will give you 0.5. 1.0 minus 1.4 will give you 0.4. 1.0 minus 0.6 will give you 0.4, and then the last one will give you minus 0.2, right? So what this minus means is we are cutting, and the one that doesn't have any negative sign in front of it is we are filling. So that is what the minus is, or the negative sign is. So we are cutting, we are filling. This existing ground level is already above what we are proposing, which is 1 meter. So we are cutting. You get? So the grid area from the question here, the grid area is 5 meters by 5 meters, right? So 5 by 5 is 25 square meters. So that's why we have it here. Now the volume is what? The grid area multiplied by the depth. Grid area multiplied by what? The depth. Yes. So want to multiply this by this. 25 by 0.5, we have 12.5. 25 by 0.4, we have 10. 25 by 0.4 we have 10, and then the last one 25 by 0.2 we have 5. Now for the adjusted volume, we already highlighted it here. The place where we have cut, we use cut. The place where we have shrink, we use shrink. So for the shrinkage value, calculated volume multiplied by this expression here. So that is how we are able to get this, right? So the final computation is to add them together. So all the old ones we are cutting, 16.25, 13.0, 6.5, you add them together, will come to 35.75. Then the adjusted fill is 13 cubic meters. So we have it here. You get, so this is just a simple way for a small site. You don't need to do much. This is just how you are going to be able, how you are going to calculate the volume of cut and fill for what you need. So the excess from this image, the dump truck is already taking it out. Once it is excavated, you take it out. Then when the parts, some of them you don't even need to even take it out, because what you have excavated you use to fill the place that needs filling. So this is just a short way of doing this thing. For more videos on construction and structural engineering, please subscribe to this channel, the Merchant Construct-preneurs and Tutors, and also hit the like button and share this content with your colleagues. See you in the next video. Thank you.